Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the 11th question from the preliminary exam which was written in the year of 2023 at St. Stithians Girls College. Please do expect a total number of 11 videos since the question paper has 11 questions in total. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. Please guys, do share the video to your peers so that they may have the same edge as you, and please do help us grow the channel by just subscribing. Okay, we are told that events A and B occur as follows. The probability of A is 0.45 and the probability of B is 0.26. If events A and B are independent, calculate the probability of A or B, right? If guys two events are independent, it simply means that probability of A and B is basically equal to the probability of A multiplied by the probability of B. If the two events are independent, right? Okay, but they want us to find the probability of A or B. So that's probability of A or B is basically the probability of A plus that of B minus the probability of A and B. Right, together, the probability of A plus that of B minus the product of the probability of A and the probability of B. I'm multiplying these two guys because we were told that events A and B are independent. Okay, so that's just 0.45 for the probability of A, 0.26 for the probability of B, and then 0.45 multiplied by 0.26. 0.45 plus 0.26 minus 0.45 times 0.26. So the final answer is just 0.593. This over here is the probability of A or B. Okay. Consider the letters of the word possibility. If the letters are arranged in any order from different arrangements, determining how many unique different ways the letters in the word can be arranged. You do not need to simplify your answer. Okay, how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our answer is just 11 factorial. But since guys we do have the same letters, we'll take them as identical events, or rather identical elements. So we have two S's over there. That sounds wrong, but that's 2 factorial because of the S's. And then I have 3 I's together, so I'm going to multiply it by 3. I'll always divide by the identical elements, guys, out together. So the total number of ways, we can leave it like this, guys, because they said you don't need to simplify and out together. But if you want to, you can simply punch your calculator. That's 11 factorial divided by 2 factorial times 3 factorial. Oh, the answer is basically 3,326,400 ways. This, guys, is the total number of ways in which you can arrange these letters. Okay. And then now we are told that if the letters are arranged in any order from different words, calculate the probability that the words formed starts with an I and ends with an S. Né? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The word is possibility. It has 11 letters, right? We are told that our word should start with an I and end with an S. And then the other letters should be arranged in any order. Are you together, guys? So before we find the probability, the number of ways in which we can achieve this order, the number of possible outcomes, I'll call it the number of p, is just 9 factorial, because the 9 letters are the ones that will occupy these available locations. Are you together? It's 9 factorial. However, within the 9, guys, remember that already we have cancelled one s and one I. So we do have letters that are identical. We have two i's now which are identical. So this is just 9 over 2 factorial. Are you together? And then the answer is just what is 9 over 2 factorial? 9 factorial divided by 2 factorial. The answer is just 181,440 ways, possible ways, ne? And hence the probability, guys, of this possible event is the number of our possible outcomes divided by the number in our sample space. This is our sample space, and then that's our possible outcomes. Ne? You can simply substitute these numbers over there, or just substitute the factorials as they are. That's 11 factorial. This is going to be 9 over 2 factorial, all divided by this is all divided by 11 factorial. 11 factorial divided by 2 times divided by 2 factorial and 3 factorial, right? This can be simplified, guys, into 9 factorial divided by, it's 9 multiplied by 3 factorial divided by 11 factorial. And then this will just give you a final answer, guys. Né? Let me just punch my calculator. 9 factorial times 3 factorial divided by 11 factorial. You'll simply get 3 over 55, which is equal to, it's a recurring decimal. Let me write it over there. That's 0.0545. This is my probability, guys. Né? If you just punch this as it is on your calculator, it was going to take you straight away to the answer. Okay, now we are told that n people numbered 1, 2, 3, 4, etc. They are arranged in a line such that n is an element of natural numbers and n is greater than 3. Find the probability that or find the probability in terms of n that the people numbered 1, 2, 3 are next to one another, or rather next to each other. Okay, so over here, guys, I already know that my sample space is just n factorial, the total number of people who are standing factorial. The number of possible outcomes, how can I find it? Remember that, guys, I have n people. But of the n people, guys, I need to subtract. I need to not count the other 3 people as single elements in our data sets, because they are just moving as a unit. Are you together? 1, 2, and 3 are moving as a unit. So I'm just going to subtract 3 because n includes that 3. Are you together? However, I'm going to add 1. Why is that? Because they are moving as one unit. They are moving as one unit. Are you together? So this factorial divided by 3 factorial. Why am I dividing by 3? Because these elements, guys, they can be placed as 1, 2, 3, 3, 2, 1, and 2, 3. Like they can be placed in many orders. Are you together? In total, there will be 6 different ways they can be placed, and it doesn't matter, guys. It doesn't matter how are they placed. They will be identified as an identical set. That's why I'm dividing by 3 factorial. Are you together? So this will end up giving me this will end up giving me a final answer of n minus 2 factorial divided by 3 factorial. Né? And therefore, the probability of this possible event taking place is equal to the total number of possible outcomes divided by the total number in the sample space. That's n minus 2 factorial all over 3 factorial divided by n factorial. So this will just be equal to n minus 2 factorial all over n factorial times 3 factorial. So this is my probability, guys, in terms of n, given that person number 1, 2, and 3 are always standing next to one another. That's how, guys, we're supposed to tackle this question over there. So please do stay tuned and wait for more videos. Thank you for your time.